Continuing with our day 3 content, we're going to now move from distribution to factoring. We're specifically going to look at factoring quadratics, and using that vocabulary, what that is referring to, a quadratic is a trinomial with 3 terms, and it comes in the form of ax squared, let me just fix that up, ax squared plus bx plus c, specifically where a is not 0. Notice if a was 0, this whole term would go away and it would be linear. It would just be like 2x plus 3, and that's just the graph of a line, right? If I made it y equals, you could easily graph that. However, when we have ax squared plus bx plus c, it might look like 2x squared plus 7x plus 3, right? And all of these have that same form where you have coefficients in front of the x squared term and the x term. And generally, these are going to be coming from, like I said in the last video, they are the product of distribution. And generally, when I ask you to factor the problem, I'm asking you to kind of go backwards and find me what were the pair of binomials that I multiplied to get to where I am now. So let's look at some strategies for factoring. Generally for factoring, the first thing you want to do is you want to make sure that the problem is as simple as possible. Sometimes factoring problems have been altered or adjusted by having a greatest common factor multiplied in, and it makes it a lot more complex. Notice this first example, there's a 4 and a 16, right, and an x squared and an x. I'm seeing that both of them have at least a 4 in common and have 1x. If I pull that out and factor that out, it's kind of like the opposite of distribution, like I said. I would think about, okay, 4x times what is 4x squared? It's just going to be an x. And then 4x times what is going to be that 16x. I need a 4. And this problem is a little bit simplified, but you could think about how you might have a problem like, instead of factoring something like x squared, like the bottom one down here, x squared plus 2x minus 15, that whole problem might be adjusted where I multiply everything by 2 and make it 2x squared plus 4x minus 30, and it looks more complex than the problem down below here is, but all it really is the first step of just taking out that 2 and leaving it in front to simplify your problem. Okay. So GCF is generally the first thing you always want to do. Most factoring problems that you've seen in the past perhaps are called trinomials. Trinomials have those 3 terms, and generally it's easiest when the value of a, which is the number right in front of the x squared term, is a 1. You can imagine a pretend 1 right there or a hidden 1 right there. So the strategy when you're factoring x squared plus 2x minus 15 is to say that it's x minus 3 and x plus 5. And the reason why is because if you envision your area model, we had the x squared, we had the minus 15, right? We're trying to think of what goes in here and what goes on the outside. I know that it has to be an x and an x, and I also know that my 2 numbers, whatever they are here and here, they have to multiply to become a 15. And remember, those coefficients are going to be the coefficient of x. So it's going to be like something x and something x. And they have to add to give me, if we look back, 2. So what 2 numbers multiply to be a 15 but add to be a 2? I know that 5 and 3 makes 15. And if I want it to be a positive 2, if I make it a positive 5 and a negative 3, notice that those like terms will combine correctly. So it's basically using your intuition and some of your factor pairs skills to figure out what did you start with that when you distributed, you got to x squared plus 2x minus 15. I've got a couple of practice problems here, so why don't you try these 2? Try and think about what multiplies to be the third term, right? You need to think about multiplying to be negative 18, but adding to be your 7. And when we look back, the a, b, and c term that they're referring to up here is if you write it out in general, multiplying to be c, but adding to be b. Okay, so try out number 1 and 2 and just see how you're feeling with just the basic trinomial factoring. Okay, here are your answers for number 1 and number 2 for the practice problems. So number one, I tried to do it in a couple different ways. I did it writing it out just like this. Some people can kind of jump to that, but I also included the area model for how you might think through. Another strategy I like to do is this strategy. I like to list factor pairs of negative 18 to help me think through. So I knew 9 and 2. I also could have listed like a 6 and a 3, and one of them would be negative, one would be positive. Same thing for number 2, like negative 2 and negative 4, negative 1, negative 8, 8, 1, thinking through just your pairs of numbers that work. And then generally what I do is I look at the numbers and I think about which numbers could give me a negative 6. And sometimes for something like 8 where the signs are positive or negative, or like the negative 18. Sometimes I'll just honestly do it like this and just list the numbers themselves, and I'll think about just which two integers, no matter if they're positive or negative, could in some way give me that 6. And I know a 1 and an 8 could add to a 9 or subtract to be a 7, and that's not going to help me. So 2 and 4 could add to be a 6, but we need it to be a negative 6, so both of them become negative. So that's just one strategy to kind of think through why the numbers I chose there work. Okay. And then you can always use your area model to help if you need. These next couple of examples, if we think back to our distribution shortcuts, we saw the difference of squares and the perfect squares. Now what you'll notice is all three of these examples, notice the outsides. All three of these. I'm just going to highlight your outside terms. Think about what do they have in common. What do you see? You should be thinking through that the numbers you see are square numbers, right? 1, 9, 49, 81. So this should be kind of a signal that a nice strategy, I'll do the first one for you guys and have you do the next couple for practice. It should be a signal that you're going to have the same thing times itself, and it's going to be a 2x times a 2x to get a 4x squared. Similarly, you're going to need a 3 and a 3 to get a 9. Sometimes the tricky thing is the sign. Notice it's a positive in the middle. All the numbers are positive, so it's going to be a plus for each of them. But remember, it's got to be the same thing times itself. So I want you to go ahead and pause the video. Try number 2 and 3 on your own. Unpause when you're ready to check your answers against my work. Okay, here is the worked out answers for number 2 and number 3. Make sure to pause the video if you need to look through any of the details. The next one we're going to look at is difference of squares. And difference of squares, remember, both of these are just a couple of shortcuts, right, to make some of the problems easier. For difference of squares, we had that same, or a different pattern, going on. Remember, it was something like if you had a plus 5 times a minus 5. Remember how the middle terms made a 5a and a negative 5a. So we could simplify that and say it's a squared minus 25. It's the same thing as a squared minus b squared. So for this one, we want to think about that it's going to be a 2x and a 2x, right? Same thing in the front, same thing in the back. And then a 9 and a 9. But remember, we need the opposite signs, as you see in the example problem, and that's what's going to cause the two terms to cancel out. So one's positive and one is negative. And that's how you would factor difference of squares. Okay, just a nice shortcut for that pattern that we see. There's some practice problems on the next page. Those are ones that you're going to want to wait until tomorrow's notes to try out, because we're going to do those in groups tomorrow. And depending on where you're failing, we're going to have some green, some yellow, some red, and I've also got some problems that are even further beyond that, just in case you're feeling really good about factoring. Okay, our last video is going to be a little bit more of different types of factoring. And another thing I'm going to show you guys in the next video is a resource that is also posted in Schoology, and it is a factoring flowchart. And the factoring flowchart is going to be a resource you have once we've kind of finished through all the different strategies. And what it will be nice is you can have this open in a separate tab as we're doing work, and you can always go back and reference this if you need to, like, double check which strategy do I use based on the problem that I'm given. Okay, so I'll see you guys in the next video. We're going to be doing a little bit more factoring. So in your book, this should be page 36, it looks like. Okay, so go ahead and flip to that and go to the next video.